Okay, locate this handout, and we're going to be working on this problem, 3.69. It's chapter 3, problem 69 in the back of the chapter. And then what we're going to do is I want you to read the problem. You can pause the video for that, and then identify the knowns. You can write them down here. I'll show you those knowns in 3 seconds to see if you got the same thing. And here they are. So the initial velocity, the total time, the acceleration of gravity, lowercase g, is always positive. On the surface of the Earth, it's 9.81 meters per second squared. And the initial position is 0. So we want to know how high. Oh, wait a minute. No, the initial position is unknown. So this is y naught up here, and this is y down here. So we should probably label this y naught with that symbol right there, and y final is on the ground like that. So we need an equation that has that one in there as well as these other ones. So we go back to the very first page. We start looking through the equations until we find one with y naught in there. And there it is right here. So then what you can do is you can write this equation down in this spot right here as part of your solution. You can do this. I want you to do this in pencil, by the way. I'm just using a word processor for my work here. Then what you're going to do is solve for y naught. And so, of course, the way that you do that is you just move this y naught to the other side of the equation. Or, I mean, I guess what you could do is just move this over to the other side like this. You'll make sure that you're subtracting it from both sides. So we're subtracting b naught t from both sides. We're also adding 1/2 gt squared to both sides so that these two things cancel out. And we just have that. Or, if you want to, you can make another line here, but I'm just going to say that gives us the value of y naught. Now, the proper way to proceed from here is to put parentheses down with everything in there. So I want you to put, for example, for this right here, I want you to put 0 meters in for that. Then I want you to put the velocity with units right in here. That's v naught. I want you to put the total time in these parentheses. Make sure you put it in seconds. And you're doing all this on paper with your pencil. And then down here, you're going to put in this one 9.81 and then meters per second. And I'm just going to use a caret. No, actually, I think I can do it too like that. So that's the value of G. And then also we're doing this right here. So make sure you put your time in seconds here. I'm just going to highlight this, hit Control, period, and it made it a square. The last thing you're going to do for this problem, obviously, is to get the answer. So see if we can get this down here. So what I want you to do is, write out the answer. This is how high the helicopter was in meters. Then I put a big box around this. I think I'll just highlight it yellow since I don't really want to put a box around it in my word processor. It's not that easy either. All right, so that's 3.69. Hints on that one. This is an in-class activity. In case you missed it, this is the video for it. Now let's go on to this one. First thing we'll do is write down the knowns and unknowns. I'll give you a moment to do that while I pause the video and go get those. So I'll show you those in a moment. Pause video and get ready. Okay, and I hope you found these for the initial velocity, acceleration due to gravity, and the final y position. We're going to consider the final y position to be right up here. We don't really know what the velocity is at that point. Really, I think we're doing is we're figuring out how long it takes to go from, let me put another shape in here, like this right here. So give that a transparent background and just put some dotted lines around there to show you that this is the region where the problem is taking place. So we have an initial velocity here. That's where the branch is. We go up all the way to the top, and then we're going to come back down over here. So we're looking for the length of time it takes to do that, even though the initial velocity is down here. All right, so I want you to select an equation for that. I'll pause the video, give you time to come up with an equation from our equation sheet. Okay, and here's some hints how to figure it out, how to figure out what the time it is going from here back to down to there. The first thing we need to do is find the velocity at this point. So if we say the initial velocity is 15 and we're looking for the final velocity, we can use this equation here because we know that y naught is 0 and then y is 7. So that's 0 and 7. This is 9.81 meters per second squared. And then that's 15. So you're going to get a velocity that's going to be right here. Then you start a new problem and you say, all right, let's look at this free fall equation that says the velocity at any point up here is going to be the initial velocity times, I'm sorry, minus GT. So since we're saying, look at the top of this up here, um, yeah, it looks like I typed in the wrong thing there, didn't I? Yeah, right here, I typed in the wrong thing. It's supposed to be right over here. Excuse me. So there's G right there. And what we could actually do is we can say that from symmetry, the total time it takes to go from here to here, the initial velocity is just the positive value of this right here. And then once we get to the end of it from symmetry, it's going to be the negative value of that. So go over here and just put a minus sign right there. You'll notice in this equation, the only unknown is t. So once you use your algebra skills to solve for t, so basically you'll subtract this from both sides of the equation, and then you'll divide by negative 9.81, keep your units throughout, and you get the answer in seconds. Let's go down to the next one here. All right, so it looks like we're saying for this one, what time does it cross the origin? It's basically saying at what time does all of this equal 0 meters? Um, and so it's understood that all of this is in meters, which is somewhat problematic because this is in seconds. So if we were to do it properly, and I'll do this in class as well, this is going to be 14 meters. And this constant right here has to be in meters per second. So that the seconds from that cancel out. All right, so we're looking for the time t. We're actually solving for that time t. We can take the meters out over here now that we put the coefficient out in front like this. Hope that makes sense. And then we're just going to put it here and say equals like that. So that means this implies that t is going to be equal to 14.0 meters divided by, if you do the algebra, so go ahead and do the algebra down here and only work on this part here. You know what, I'll just do it for you because this is what I'm supposed to be doing anyway. All of this, we need to add it to both sides of the equation. So we just put it over here, and then it cancels out like that. Then you solve for t, and you get t is equal to, you can see clearly, it's going to be something divided by something else. I'll let you put those two things in right there using your algebra skills, and we're going to get an answer over here. So make sure this right here is going to be in meters. That's the 14. Here's the 28. So it's like it's going to take a half of a second, if you ask me. Let you do the algebra work, of course. So make sure you put your numbers in here. Always include your units throughout your solution. Okay, looking at the next one. Now let me make sure that I have the videos that we need here. So I'm looking right here, and then we go into chapter 3, and I'm just trying to see which videos I need to provide to you all. Here it is right here. So I need to go down to 35. So I did 69, and I believe that was 74 right there. So 69, 74. And I just did 27. And so is my last one going to be 35? It is, so that the rest of the rest of these videos will cover everything else. So just one more here. And so what we do is we take this equation and let's correct it like we did the other one. Since this has to be positioned, this has to be 100 meters per second. It needs to be that way so that the seconds here will cancel out and give you meters at the end. And so what do you think the units on 20 would be if we did it correctly? The textbook kind of leaves that out. Now they just put a meter out to the side, but I like putting the units in here, so meters per second square. And you see that second square is going to cancel out. And did I do it the right way? So that you get meters on the on that part of it. And of course, what you want to do is use the derivative that we discussed in class. I wonder if it's actually on here. No, but it is on the board. Yeah, okay. So then we're going to find the velocity, which is going to be d by dt of, I guess we can do this, dx dt. So it's basically the derivative of the x function. So solving for that, come back over here, it looks like to me, if I take the derivative of this, it's just going to be the constant. And then right here, it's going to be dt, which is basically going to be a 1 right there. And if we do this one, you'll remember from your from our notes in class, this is going to be 2 times t. So you pull the 2 down, and then you leave the t over there like this. And so we're going to say at 12 seconds. So to wrap this one up, just put a 12 here. Now this means as a function, in other words, this means v as a function of time, and we're saying evaluate it at t equals 12 seconds. That means that all we got to do is put 12 seconds right there. So that means we're going to get v at 12 seconds. See if we can do this one in our head. We get 100 right here. We get 24 from that times this right here. Looks like 480, I think. And then you're subtracting that. So maybe negative 380. I'll let you double check the math on that one. Notice that the units will work out so that you get meters per second because you have meters per second square here and one of the seconds gets canceled out. So 12 times 2 times that. And then all of that's being subtracted from 100. All right, that should get you started or get you wrapped up with the in-class activities in case you missed them. All right, I'll see you soon.